Hello guys and welcome to my channel. In this session, we want to talk about stakeholder needs and requirements definition process. If you want to find out more about this concept, then don't miss this training session. And as always, have a good one. As I stated in ISO IEC IEEE 15288, the purpose of the stakeholder needs and requirements definition process is to define the stakeholder requirements for a system that can provide the capabilities needed by users and other stakeholders in a defined environment. Successful projects depend on meeting the needs and requirements of the stakeholders throughout the lifecycle. A stakeholder is any entity, individual, or organization with a legitimate interest in the system. When nominating stakeholders, business management will take into account all those who may be affected by or able to influence the system. Typically, they would consider users, operators, organization decision makers, parties to the agreement, regulatory bodies, developing agencies, support organizations, and society at large within the context of the business and proposed solution. When direct contact is not possible, systems engineers find agents such as marketing or non-governmental organizations to represent the concerns of a class of stakeholders such as consumers or future generations. After identifying the stakeholders, this process elicits the stakeholder needs that correspond to a new or changed capability or new opportunity. These needs are analyzed and transformed into a set of stakeholder requirements for the operation and effects of the solution and its interaction with the operational and enabling environments. The stakeholder requirements are the primary reference against which the operational capability is validated. To achieve good results, systems engineers involve themselves in nearly every aspect of a project, pay close attention to interfaces where two or more systems or system elements work together, and establish an interaction network with stakeholders and other organizational units of the organization. Below figure shows the critical interaction for systems engineers. The stakeholder requirements govern the system's development and are an essential factor in further defining or clarifying the scope of the development project. If an organization is acquiring the system, this process provides the basis for the technical description of the deliverables in an agreement, typically in the form of a system level specification and defined interfaces at the system boundaries. Below figure is the IPO diagram for the stakeholder needs and requirements definition process. Inputs and outputs for the stakeholder needs and requirements definition process are listed in the below figure. The stakeholder needs and requirements definition process includes the following activities. Prepare for stakeholder needs and requirements definition. Determine the stakeholders or classes of stakeholders who will participate with systems engineering to develop and define the stakeholder needs and translate these into system requirements, phased throughout the entire life cycle. Capture these results in the CONOPS. Determine the need for and requirements of any enabling systems, products, or services. Define stakeholder needs. Elicit stakeholder needs from the identified stakeholders. Prioritize the stakeholder needs to identify which to focus on. Specify the stakeholder needs. Develop the operational concept and other lifecycle concepts. Identify the expected set of operational scenarios and associated capabilities, behaviors, and responses of the system or solution and environments across the lifecycle in acquisition, deployment, operations, support, and retirement. The scenarios are built to define the lifecycle concept documents, the range of anticipated uses of system products, the intended operational environment and systems impact on the environment, and interfacing systems, platforms, or products. Scenarios help identify requirements that might otherwise be overlooked. Social and organizational influences also emerge from using scenarios. Define the interactions of the system or solution with the users and the operating, support, and enabling environments. Transform stakeholder needs into stakeholder requirements. Identify constraints on the solution imposed by agreements or interfaces with legacy or interoperating systems. The constraints need to be monitored for any interface changes, external or internal, that could alter the nature of the constraint. Specify health, safety, security, environment, assurance, and other stakeholder requirements and functions that relate to critical qualities. Specify stakeholder requirements consistent with scenarios, interactions, constraints, and critical qualities. Analyze stakeholder requirements. Define validation criteria for stakeholder requirements. Stakeholder validation criteria includes measure of effectiveness and measure of suitability, which are the operational measures of success that are closely related to the achievement of the mission or operational objective being evaluated in the intended operational environment under a specified set of conditions. That is, how well the solution achieves the intended purpose. These measures reflect overall customer or user satisfaction. For example, performance, safety, reliability, availability, maintainability, and workload requirements. Analyze the set of requirements for clarity, completeness, and consistency. Include review of the analyzed requirements to the applicable stakeholders to ensure the requirements reflect their needs and expectations. Negotiate modifications to resolve unrealizable or impractical requirements. Manage the stakeholder needs and requirements definition. Establish with stakeholders that their requirements are expressed correctly. Record stakeholder requirements in a form suitable for maintenance throughout the system lifecycle and beyond or historical or archival purposes. Establish and maintain through the lifecycle a traceability of stakeholder needs and requirements, for example, to the stakeholders, other sources, organizational strategy, and business or mission analysis results. Provide baseline information for configuration management. Within the context of ISO IEC IEEE 15288, requirements or business stakeholder and system are drivers for the majority of the system lifecycle processes. Depending on a system development model, stakeholder requirements capture should be conducted nominally once near the beginning of the development cycle or as a continuous activity. Regardless, the reason for eliciting and analyzing requirements is the same. Understand the needs of the stakeholders well enough to support the architecture definition and design definition processes. Identify stakeholders. Systems engineers engage with legitimate stakeholders of the system. The major stakeholders at the business management level will have been nominated during the business or mission analysis process. Here, systems engineers are interested in identifying stakeholders from the business operations level. One of the biggest challenges in system development is the identification of the set of stakeholders from whom requirements should be elicited. Customers and eventual end users are relatively easy to identify, but regulatory agencies and other interested parties that may reap the consequences of the deployed system should also be sought out and heard. Stakeholders can include the stakeholders of interoperating systems and enabling systems, as these will usually impose constraints that need to be identified and considered. In sustainable development, this includes finding representation for future generations. Elicit stakeholder needs. Determining stakeholder needs requires the integration of a number of disparate views, which may not necessarily be harmonious. As the SE process is applied, a common paradigm for examining and prioritizing available information and determining the value of added information should be created. Each of the stakeholders' views of the needed systems can be translated to a common top level system description that is understood by all participants and all decision making activities required for future examination. Under some circumstances, it may not be practical to elicit needs from the stakeholder but rather from the marketing organization or other surrogates. There may be stakeholders who oppose the system. These stakeholders or detractors of the system are first considered in establishing consensus needs. Beyond this, they are addressed through the risk management process, the threat analysis of the system, or the system requirements for security, adaptability, or resilience. Systems engineering should support program and project management in defining what must be done and gathering the information, personnel, and analysis tools to elaborate the business requirements. This includes gathering stakeholder needs, system or project constraints, for example, costs, technology limitations, and applicable specifications or legal requirements, and system or project drivers, such as capabilities of the competition, military threats, and critical environments. The outputs of the stakeholder needs and requirements definition process should be sufficient definition of the business and stakeholder needs and requirements to gain authorization and funding for program initiation through the portfolio management process. The output should also provide necessary technical definition to the acquisition process to generate a request for proposal or RFP if the system is to be acquired through a contract acquisition process or to gain authorization to develop and market the system if market driven. These outputs can be captured in lifecycle concept documents, particularly the OPSCON and the STRS, which often are used to support the generation of a statement of work and or an RFP, both of which are artifacts of the acquisition process. Contributing users rely on well-defined completion criteria to indicate the successful definition of user and stakeholder needs. User organizations have gained authorization for new system acquisition. Program development organizations have prepared a SOW, STRS, and gained approval for new system acquisition. If they are going to use support from outside the company, they have issued an RFP and selected a contractor. Potential contractors have influenced the acquisition needs, submitted a proposal, and have been selected to develop and deliver the system. If the system is market driven, the marketing group has learned what consumers want to buy. For expensive systems, for example, aircraft, they have obtained orders for the new systems. If the system is market and technology driven, the development team has obtained approval to develop the new system from the corporation. Since requirements come from multiple sources, eliciting and capturing requirements constitutes a significant effort on the part of the systems engineer. The OPSCON describes the intended operation of the system to be developed and helps the systems engineer understand the context within which requirements need to be captured and defined. Techniques for requirements elicitation include interviews, focus groups, the Delphi method, and soft systems methodology, to name a few. Trade off analysis and simulation tools can also be used to evaluate mission operational alternatives and select the desired mission alternative. Tools for capturing and managing requirements are many and varied. The source requirements captured by carrying out this activity are only a portion of the total stakeholder requirements. As such, source requirements will be expanded by a number of activities designed to break down the broad requirement statements and reveal the need for additional clarification, which will lead to either revision of the written source material or additional source documents, such as meeting minutes. Initialize the requirements database. It is essential to establish a database of baseline requirements traceable to the source needs and subsequently to system requirements to serve as a foundation for later refinement and or revision by subsequent activities in the SE process. The requirements database must first be populated with the source documents that provide the basis for the total set of system requirements that will govern its design. Develop the lifecycle concepts. The word scenario is often used to describe a single thread of behavior. In other cases, it describes a superset of many single threads operating concurrently. Scenarios and what if thinking are essential tools for planners who must cope with the uncertainty of the future. Scenario thinking can be traced back to the writings of early philosophers such as Plato and Seneca. As a strategy planning tool, scenario techniques have been employed by military strategists throughout history. Building scenarios serves as a methodology for planning and decision making in complex and uncertain environments. The exercise makes people think in a creative way. Observations emerge that reduce the chances of overlooking important factors, and the fact of creating the scenarios enhances communications within and between organizations. Scenario building is an essentially human activity that may involve interviews with operators of current or similar systems, potential end users, and meeting of an interface working group or IFWG. The results of this exercise can be captured in many graphical forms using modeling tools and simulations. Creation or upgrade of a system shares the same uncertainty regarding future use and emergent properties of the system. The stakeholder needs and requirements definition process captures the understanding of stakeholder needs in a series of lifecycle concept documents, each focused on a specific lifecycle stage: acquisition concept, deployment concept, OpsCon, support concept, and finally, retirement concept. A primary goal of a concept document is to capture early in the system lifecycle and implementation free understanding of stakeholder needs by defining what is needed without addressing how to satisfy the need. It captures behavioral characteristics required of the system in the context of other systems with which it interfaces, and captures the manner in which people will interact with the system for which the system must provide capabilities. Understanding these operational needs typically produces a source of specific and derived requirements that meet the needs and objectives of the customer and user. Invaluable insight for SE and designers as they define, design, develop, verify, and validate the system. Diminished risk of latent system defects in the delivered operational systems. If the system is for a military customer, there may be several required views of the system driven by architectural frameworks. The primary objective is to communicate with the end user of the system during the early specification stages to ensure that stakeholder needs, or particularly the operational needs, are clearly understood and the rationale for performance requirements is incorporated into the decision mechanism for later inclusion in the system requirements and lower level specifications. Interviews with operators of current or similar systems, potential users, interface meeting, IPO diagrams, functional flow block diagrams or FFBD, timeline charts, and N-squared charts provide valuable stakeholders input toward establishing a concept consistent with stakeholder needs. Other objectives are as follows. 1. To provide traceability between operational needs and the captured source requirements. 2. To establish a basis for requirements to support the system over its life, such as personnel requirements, support requirements, and etc. 3. To establish a basis for verification planning, system level verification requirements, and any requirements for environmental simulators. 4. To generate operational analysis models to test the validity of external interfaces between the system and its environment, including interactions with external systems. 5. To provide the basis for computation of system capacity, behavior under or overload, and mission effectiveness calculations. 6. To validate requirements at all levels and to discover implicit requirements overlooked from other sources. Since the preliminary lifecycle concepts have provided a broad description of system behavior, a starting point for further developing the concept is to begin by identifying outputs generated by external systems or modified as appropriate by passing through the natural system environment, which act as stimuli to the SOI and cause it to take specified actions and produce outputs which in turn are absorbed by external systems. These single threads of behavior eventually cover every aspect of operational performance, including logistical modes of operation, operation under designated conditions, and behavior required when experiencing mutual interference with multi object systems. Aggregation of these single threads of behavior represents a dynamic statement of what the system is required to do and how it is to be acquired, deployed, operated, supported, and retired. No attempt is made at this stage to define a complete OPSCON or to allocate functions to hardware or software elements. This comes later during architectural design. Well, the lifecycle concepts are essentially definitions of the functional concepts and rationale from the stakeholder perspective. The lifecycle concepts are further developed as follows. 1. Start with the source operational requirements. Deduce a set of statements describing the higher level mission oriented needs. 2. Review the system needs with stakeholders and record the conflicts. 3. Define and model the operational boundaries. 4. For each model, generate a context diagram to represent the model boundary. 5. Identify all of the possible types of observable input and output events that can occur between the system and its interacting external systems. If the inputs or outputs are expected to be significantly affected by the environment between the system and the external systems, add concurrent functions to the IPO diagram to represent these transformations and add input and output events to the database to account for the differences in event timing between when an output is emitted and when an input is received. 7. Record the existence of a system interface between the system and the environment or external system. 8. For each class of interaction between a part of the system and an external system, create a functional flow diagram to model the sequence of the interactions as triggered by the stimuli events generated by the external systems. 9. Add information to trace the function timing from performance requirements and simulate the timing of the functional flow diagrams to confirm operational correctness or to expose dynamic inconsistencies. Review results with users and operational personnel. 10. Develop timeline approved by end users to supplement the source requirements. Generate the STRS. A draft STRS should be generated to formally represent the stakeholder requirements. The STRS should be traceable to the stakeholder needs and to the BRS.